as I said yesterday, if you can draw the graph, then domain and range becomes real easy. So knowing the basic shape of graphs, what's it going to look at, is quite important. So let's just go over some of them. Well, first of all, some basic ideas. Remember, numbers on your axes should be evenly spaced. That doesn't necessarily mean the scale on the y-axis has to be the same as the one on the x-axis. Mind you, there are some shapes where you really do need it to be the same. For example, well, I was going to say a circle. If the scale's not the same on the x and the y, the circle is going to be a little bit distorted. So in that case, it would be good. Right. Y-intercept, of course, very easy to find out. It's when x equals 0, just sub 0 in, bang. And the x-intercept, you solve the equation y equals 0. They tend to be key points. Mind you, on that with the x-intercept, if it's a difficult equation to solve, I tend to not worry about it. I mean, if it's just a sketch. So once you know your intercepts, if you know the basic shape, then drawing the curve in, piece of cake. So, and never forget the basic idea from maybe year 7 or even earlier than that. You are allowed to substitute numbers in and plot points. So if you're unsure what a curve is doing, just plot some points and get a feel for where the curve's going. Right. The basic curves. The most basic curve is not really a curve, but a line. And the most basic straight line is y equals x. There it is. Isn't that beautiful? Now, how do you recognize a straight line? That's right. Y equals mx plus b is a straight line. So you see the equation, y is to the power of 1. X is also to the power of 1. I've got a straight line. And we've got other pieces of information which we know, of course, that m would be the slope of the line and b would be the y-intercept. All right, well then we up it a bit. We go parabola. The most basic, y equals x squared. Of course, the general one is ax squared plus bx plus c. Again, how do you recognise? Look at that. Y is to the power of 1. X is to the power of 2. That's a quadratic. It's a parabola. So hopefully we recognise those sort of shapes. X-intercepts, solve the quadratic equation. Vertex, always going to be halfway between the x-intercepts because of the symmetry of the shape. Let's do a quick one. Y equals x squared minus 4x plus 3. All right, I'm going to do it by completing the square here. Y equals x minus 2 squared minus 1. Why did I do it that way? Because that tells me how the shape has shifted. It's grouped with the x, so that tells me horizontally it's moved 2. And then minus 1, it's moved down 1. I know the vertex is going to be at the point 2, 1. So that's the advantage of using completing the square on an equation. You can, bang, get a picture straight away. X-intercepts turn out to be, what are they? 1 and 3. 1 and 3. Quick little sketch. 1, vertex, 3. Whee! There it is. Didn't even bother marking the y-intercept on that one. All right, cubic then becomes the next one. There's a very dodgy cubic. Y equals x cubed. It inflects. The most basic one actually is what we call a horizontal point of inflection. Much better example over there on the wall, of course. As a polynomial, we would write it out, ax cubed plus bx squared plus cx plus d. Not all cubics, of course, look like that. Only the ones that can be factorised as a perfect cube look like that. So 1's to the power of 1, 1's to the power of 3. That's how we recognise it's cubic. As I say, only ones that are factorised will look like that. Otherwise, it'll be that classic shape where you have 2 turning points, so you sort of go up and down. So otherwise the cubic will look like that. Higher powers. Right. Anything to an even power will have that U shape. Only the squared is called a parabola. The others still have a U shape. But what happens is as the power gets higher, the U gets flatter at the base, steeper at the sides. Steeper at the sides. And so similar with our cubics or our odd powers. They all have that twisting shape or inflecting shape. But again, steeper at the base, flatter at the base, steeper at the sides as the power goes up. Okay. Probably the next shape we saw was the hyperbola. And the most common hyperbola, y equals 1 on x, or sometimes we see it written as xy equals 1. How do I recognise it? Well, basically, if I see a function and the pronumerals in the bottom of the fraction, one of the pronumerals, I'm probably going to have some sort of asymptote in there, some sort of hyperbolic function. All right. Circle. There we go. X squared plus y squared is the radius squared. Now, the pronumerals are both to the power of 2, and the coefficients are the same. Right, so 2x squared plus 2y squared is still going to be a circle. If the coefficients are different, what do you get? An ellipse, yeah. Unless, of course, the sign's different as well. So if the sign is different, so say instead of x squared plus y squared, you had x squared minus y squared. So anyone know what you get there? You actually get a hyperbola. But not in that classic shape there. It would be rotated 45 degrees. And so it sort of goes that way. We'll learn a lot more about that in extension 2. Exponential. The basic exponential looks a bit like that. Always has a y-intercept of 1. Now, that's assuming the base is bigger than 1. So y equals a to x. How do you recognise it? Oh, look, the pronumeral's in the power. That's why we call it an exponential, because another name for power is index, but another name for it is exponent. Exponent. Roots. Basically, roots are going to be 2 halves of another shape. So here's y equals the square root of r squared minus x squared. There we go. There's y equals the square root of x. If you didn't recognise it, just square. Get rid of the square root sign, see what happens. See? Get rid of the square root sign, rearrange it. Ah, it was a circle. But because it's a square root, it's the top half. Negative square root, be the bottom half. And over there, y equals square, I don't know what it is. Square it. Oh, look, one of the pronumerals is the power of 2, the other is the power of 1. Must be a parabola on its side in this case. Yeah. So remember the positive square root, top half. Negative square root will be the bottom half. All right, that's enough for today.